Okay, I'm now getting into my talk about homesteading. I was thinking, what's the use of spending all this effort taking these little tiny tin cans to live in when what you want to do is live there and set up a permanent base and eventually a settlement. And I looked at the way pioneers have in the past settled new places on Earth and say, why do we do that? We don't need a lot of aerospace engineer designed aluminum habitats to live in. Let's not bring our houses from Earth. In the past, homesteaders have always used local materials, simple tools, and they basically put up with a lot of hardship and work hard, take some risks, and they have to adapt to the current environment and change plans. You're not going to find logs on Mars, obviously. So what resources are there? Every chemical, every element you need to live is on Mars. And even if this is a review, bear with those in the audience who haven't seen this before. The air is 95% carbon dioxide at 1% of Earth's pressure. There is about 2% of nitrogen and argon. There's a trace of water, and of course there's lots of carbon that you need to grow plants in the air. There's also lots of dirt. Slightly different chemical composition, but there's a good chance you could grow crops in it. You might have to leach it to get the salts out, since that hasn't been done by natural processes there. There's sunlight, and interestingly enough, the daytime is 24 hours and 39 minutes and some odd seconds long. So those of you who always wanted an extra 40 minutes in the day, maybe you were destined to go to Mars. If you tend to sleep late in the morning and always have trouble going to bed, you're a natural-born Martian. That was the good part. The last slide is the good part. This is the bad part. Your blood would boil, low pressure, it's low temperature. I say 215 Kelvin, that's about negative 60 degrees centigrade. However, the temperature extreme is not as bad as on the moon. That is, it's not as cold as the lunar night, it's not as boiling hot as the lunar day. And with the air so thin, it actually doesn't chill you that much. It doesn't chill you as much as minus 60 degrees centigrade would on Earth. You need to be protected from radiation. The dust storms, I personally don't think there'll be that much of a problem, because the heavy dust doesn't get above about waist high. And a lot of sunlight still comes through in spite of the dust storms. Hello, Bob. You are very far from help. There's like 2-year launch windows to get help. Okay. I was going to show you the physical data from Mars, but I think in the interest of time, let's skip that. Basically, I have a chart of 3 decimal places of what the various chemical compositions are. So we'll skip that. You can see me afterwards. Okay. This is a bad design for an early base anywhere, because it has big sheets of glass that are under heavy pressure. You've got to make steel and concrete. This would take a big industrial base to produce this kind of construction. This is the raw material you have to work with. We don't. Some people say we don't have a lot of experience working with this material, but we do. This, in fact, is not Mars. This is coral pink sand dunes, I think, in Utah. And the people who live there built houses something like this. They built with mud, absolutely minimal wood. Here's a different part of the world showing the kind of construction using resources that you would find on Mars. Looks boring, it is. Notice the tools that these people use. 4 55-gallon oil drums and something like a shovel and some buckets. Now, I'm not saying that the astronauts would be, shoveling dirt out of it, but you could get by with some very small, semi-automated machinery to, say, compress bricks. This brick compression will double the strength of a building brick. You can easily imagine a motor on Here's a machine to sift sand and gravel. You can make smaller versions. If this particular machine broke, you can improvise using a garbage can, an electric motor, and some water stream. So the simpler the building material technique, the simpler the building materials and the simpler the techniques, the more chance you have of repairing your tools or improvising tools. You need a solar furnace or some other heat source to fire the brick. I took this design and said, okay, let's make the first Mars habitat something like this. So I made sort of a brick Quonset hut, 2 stories high with tunnels connecting it elsewhere. And this was my design that I presented at the Case for Mars conference. As I worked out more and more in the engineering details, I realized that it'd be better to line up a bunch of arches end to end like this, so that the forces pushing the arch outward are resisted by another force. These are actually vaults. That is, they would continue and there'd be a room under each one of them. You cover them with regolith to hold the air pressure. So those A arrows pointing up are the air pressure trying to explode the building. You have about 7 meters of regolith or dirt on top of it, holding that pressure down. And in the middle, between the 2 arches, right there, are some little buttresses. When you remove the air pressure, say if you have to depressurize it for repairs, the direction of the forces change. The direction of the net force changes, and so you need these buttresses and the arches designed appropriately. Here's a real-life example. These buildings are very permanent. This is from Pompeii. As in before it got covered by the volcano. You can see the buttress on the far right. Here's my design made in clay. Here's another example that's about 3,000 years old from Egypt. Okay, can someone help me set up, pull the overhead projector in? So the basic idea is you would build brick vaults, and the air pressure is, the regolith on top holds the air pressure in. You would line the inside of the vault with plastic to keep the air from leaking. You also have to line the floor. You would have, I'm going to spill these view graphs. You might want to move it closer. Okay, you would also have to bring your airlocks from Earth. You bring emergency life support systems from Earth. You rely on greenhouses as much as you could. Here I have a couple layers of plastic with sand in between, so that if one layer has a leak, you can pull a suction and suck air out from between the 2 layers and recover some of your lost air. This is a 2-story design. I have a 2nd floor made of perhaps locally produced bamboo, although the very first one might be from aluminum scavenged from a cargo craft. Down on the floor, I also have multiple layers of plastic and some of the leftover bricks as a paved floor. So that's my basic design, and the rest of the talk is variations on it. Comments?
Why 2 stories?
Why 2 stories? It's to save construction effort. You build it 2 stories high, and then at your leisure, you finish the inside. I should have mentioned the advantage of this over, say, poured concrete. If you want to pour a big concrete building, you got to make a formwork as big as the building, or you have to work in an area as big as the building. Brick construction, you can make the brick indoors in a really tiny space, then you use the bricks to make a larger space. So a lot of your work can be indoors. I designed a construction tent. You would first dig trenches and lay your foundations and build up a couple rows of brick. Then you would make this giant puffy thing, and then you could pressurize the insides with carbon dioxide, walk around with scuba diving oxygen masks, and work inside there. Ideally, most of the work would be done by robots. So you build up your walls inside this construction tent, put up the formwork and make the arches. Here's a detail of, say, the lower wall, and in the interest of time, let's keep going. Basically, multiple layers of plastic. Oh, here are the figures of, never mind. I was saying let's put 700 millibars of pressure, 7/10 of Earth's atmospheric pressure inside.
How much space are you allocating to greenhouses?
I didn't get down to details like that. As far as space, but I will touch on greenhouses. Okay, let's switch back to slides.
What's your atmospheric composition? Not pure oxygen.
Yes, it would be, on Earth we have 20% oxygen. You probably want about the same pressure of oxygen.
Right.
So you might have a lower total pressure, but have 30% oxygen. The nitrogen is needed for the plants, nitrates and fertilizer. So you probably end up using a lot of argon inside your habitat. And argon and nitrogen are about equally abundant. We just pay lip service that you need formwork. This is one of my favorite slides. You might be able to make some formwork out of scraps from whatever landing craft you have. This is a crashed spaceship. Notice the curve is just the shape of my balls. If you want to do an odd shape, you don't need a special form. Here they use bricks to make an ad hoc form. So this is what some of the buildings on Mars might look like. This is from New Mexico. Preferably you'd use cement for mortar, but a lot of buildings are built here on Earth with mud mortar. This is the inside of that building, showing passageways through the walls, and then the vaults are over them. Let me go on to windows. At the ends of the vaults, it'd be nice to have windows. And you might be able to produce glass locally and fill in small window panes. Remember, there'd be 7 meters of regolith above the arch on the left, holding it down. So as this settlement gets established, the first products you're likely to be able to make easily are glass, fiberglass, and then cement, and later concrete, and products from greenhouses, bamboo, rubber. Okay, here's what the interior of one of these spaces might look like with windows on the end. This, I believe, is from Nigeria. Another view. You can use glass and brick and ceramics for interior partitions. You're not going to have a lot of wood. You could make paper and felt. Here's a concrete chess table. You're much more likely to have. This would be much cheaper on Mars than an aluminum table brought from Earth. Another possible interior furnishings. Okay, ideally these would be constructed down low. In other words, you might pick a crater or you excavate a bit, build them down low, and cover them with dirt. But you could arrange some nice patterns. You could build it in a crater, like as shown here, or have kind of a circular pattern, with a bunch of arches facing out over the top of the crater, and then 7 meters of regolith piled on top, sandbags to keep from spilling over the edge. This is from Monterey, California. At the center of the crater, you might have a nice dome with a skylight. There's a lot of other shapes and variety you can build into it. Here are different possible vaults and domes and intersecting vaults you can build. The finished thing might look like this from England. You can see a bunch of vaults over there covered with dirt and green grass on top. It turns out fortifying yourself from radiation is not that dissimilar from fortifying yourself from cannon shells being shot at you in the 1800s. Okay, in the event that you didn't get a lot of supplies from Earth, and you know, a civilization on Mars kept growing, you could build some very substantial structures using local materials. The Romans could have built on Mars if we had given them pressure suits. They had enough, you know, technology to build buildings suitable for Mars. So I said, you know, could we build something this big on Mars using almost nothing brought from Earth? And I designed this structure, 6 stories high, 3 floors of masonry, interior, and every other floor would be wood or bamboo or fiberglass. Here's the sort of scale. This is, I think, 1,500 years old, 25 meters across, 27 meters high. So it's a pretty big structure. This is what the atrium might look like. You'd have, there are 6 stories on the right. The lower floors might be light industry and laboratories. The middle floors might be shops and restaurants and administrative offices. The upper floors would be condominiums. And there are windows on the left, and you plant your valuable long-term plants in this atrium, your fruit trees, the ones that you don't want to risk in a greenhouse, where you want the tree to be safe for 20, 30 years. So here's a artist's conception of that atrium on Mars with the windows on the left. Here's another example from Cleveland, Ohio, what the atrium might look like. You could build 2 of these side by side, put mirrors on the back side of one, focusing sunlight in through the windows, greenhouse on top. I'm concluding the construction techniques, and you can see the contrast between building with local materials, bricks and stone, versus importing stuff from Earth. So instead of this construction technique, I think we're more likely to have this construction technique after people start learning to live on Mars. Okay, there's mention of plant products. I'll go through this even faster. This is a composting greenhouse on Cape Cod. This is my water treatment plant. You may think it's a water hyacinth. I call it a water purification plant. It's a lot cheaper to bring the seeds from Earth than to bring the equipment, than to bring mechanical water treatment from Earth. And the roots, lo and behold, filter impurities out of the water. You're supposed to be able to see little root hairs there. This is a composting toilet. It's a big fiberglass tank. It's very simple. It's not the most elegant waste disposal technique, but it's effective. You can make one out of local brick or fiberglass. Okay, as far as what greenhouses might look like, you don't want giant greenhouses with big flat panels. You want something that will take the pressure better, that has the right curvature. Even this, if it was blown up to a high pressure, would just lift itself off the ground and turn into a ball. Incredible force to hold it down. So my greenhouses would look like air mattresses, giant air mattresses big enough to walk around in. Here's the inside of one. I apologize for the quality of the slides. You might have 2 layers of transparent fabric on top, held down with basically cables, 2 layers on the bottom, and walkways and hanging plants. The condensation condenses on the top, drips down onto the plants.
Very down and back in the future, your apologizing for the quality of your slides.
I'm sorry. Yeah. Let's skip those. This plant they tried to make rubber out of during World War II. With today's technology, I think they'd have a better chance. So there's a lot of plant products you can use in everyday life. So you can make some fraction of a spacesuit from greenhouse-grown materials. There's a bamboo plant I mentioned earlier. Use that for interior furnishings. You might want to put a wind fence up to try to harvest the wind-blown dust, or at least keep it out of some heat spot. Anyway, I think I forget this is my concluding slide, but I forgot my conclusion. Anyway, so that concludes what should have been a 1-hour presentation on homesteading Mars.